Hey there, we're going to continue learning about graphing quadratic functions, and we're going to switch our focus from where we were graphing functions, quadratic functions whose equation is written in standard form, to graphing quadratic functions whose equation is written in turning point form that you see right here. Alright, now this slide that I'm about to show you is exactly the same thing that was in the previous video because we're still graphing parabolas. And whenever we're graphing parabolas, it doesn't matter what form the equation was written in, you're still looking at the line of symmetry, you're still looking for the vertex, and you're still looking at the intercepts or other points that aren't on the axis of symmetry in order to make the graph of the parabola. Alright, that doesn't change just because the way the equation changes. So, we'll keep working with these three things. Okay, now this is what's called turning point form right here, and I've got it labeled at the top. Let me label that as turning point form as well. Okay, also known as vertex form, depending on what textbook you're looking at, but IB will refer to it as turning point form the majority of the time. Well, truly, they'll refer to it using the equation. They'll just say write the equation or graph the equation that's in the form of y equals a times x minus h squared plus k. Alright, now the purpose of this slide is to talk about the steps that you go through whenever you're trying to graph something that's written in turning point form. And it turns out the basic process here is the same as when it's in standard form because you're still trying to graph the same type of thing. Okay? Still need to know where the axis of symmetry is. You still need to find the coordinates of the vertex, and you still need to find the coordinates of one point that's not on the axis of symmetry and use symmetry to reflect that and sketch the other half of the graph. Alright, we're going to come back to this slide a little bit later on, and I'll be more specific about how you find each of these things right here. But what I'd like to do is go ahead and get started with actually sketching some equations that are written in turning point form. But I want to show you how they're created really, because if I can help you make this connection right here, turning point form is going to be a very simple thing. And the connection I'm referring to is I want you to make a connection between graphing parabolas and writing the equations of functions whenever you're trying to translate them or stretch them or reflect them, as we did in chapter 1. And so here's what we're going to do. We're going to sketch a graph of y equals x squared. I know that doesn't look like turning point form. It doesn't look like standard form. It's actually the most basic of either form, to tell you the truth. We're going to sketch a graph of y equals x squared here momentarily. And then we're going to write an equation for a translation of that graph that would go 2 units to the right and 3 units down. And we're going to sketch its graph on the same axes. Alright, so make sure you have some graph paper handy. And let's go ahead and get started on graphing y equals x squared. Alright, now the equation y equals x squared truly is in standard form, what we were looking at before, and you know how to graph a standard form equation. You find the axis of symmetry, you find the vertex, and then you pick a point not on the axis of symmetry and use reflection to make the rest of the graph. That's what we said a few moments ago actually. However, what people don't realize, and it makes this a whole lot more complicated than it is that when you see the equation y equals x squared, the values of b and c are equal to 0. Right? I could write this equation as y equals x squared plus 0x plus 0, and it would be the same thing. And so the reason why I bring that up is it's very easy to find out where the axis of symmetry and vertex are. If we're looking at the axis of symmetry, I'll abbreviate that way, well, the opposite of b is 0, and 0 divided by anything is 0. X equals 0, or the y-axis, is the axis of symmetry. Okay, so I don't have to regraph the axis of symmetry because the y-axis is the axis of symmetry. Alright, and then as far as the vertex goes, well, we're going to plug in 0 into the function, and that's just going to give us y equals 0 squared, which is 0. So the vertex is the origin. So I'll go ahead and plot that here. Okay, now here's a situation we didn't encounter in the previous video. The axis of symmetry is the y-axis. And so for this next part, when we try to find a point that's not on the axis of symmetry, we can't use the y-intercept to do that anymore. Okay, and we can't actually use the x-intercept either because, well, this single point is the x and y-intercept and it's the vertex all in one. So if we just try to go through the same strategy we did last time, we're never going to get the rest of this graph. Well, if we follow the words that I said, though, instead of what I actually showed you, then we're going to be able to come up with this pretty easily. All I really said you have to do is pick some value, find a point that's not on the axis of symmetry. All right, so let's look at not on the axis of symmetry. And I could pick any value I want to that's not on the axis of symmetry and try to find its x and y coordinate. And so let's say that I want to find out where the parabola would cross through this line x equals 2. All right, so I'm going to find out what f of 2 is. Now f of 2 is going to be 2 squared, or just 4. I should really erase the rest of this equation. We don't need it anymore. Right, so we're just going to get 2 squared, and that's going to equal 4. And so the graph will go through the point 2, 4. Right there. And then I can just simply reflect that in the y-axis, because that's axis of symmetry. That'll reflect the negative 2, negative 4, and then I've got the graph. Alright, the graph y equals x squared is absolutely the simplest quadratic equation that you can graph. Alright, now on the same set of axes, we are going to do this now. We're going to go ahead and try to translate that graph 2 units right and 3 units down. And we're going to write what its equation would look like, and we're going to make the actual graph. Now I'm pretty sure that's the 3 units down. I might have said, oh, I can't see that problem right now, and I can't go back and look at it without losing my progress here. So let's just say we're going to translate it 2 right and 3 down, despite whatever the directions might have said earlier. Okay, well, what I need you to recall is, how do you take a function and translate it? How do you manipulate its equation for a translation? And so what you might recall is that if you want to translate a function horizontally, use f of either x plus h or x minus h, depending on if you want to go right or left. And in this case, we want to go to the right. So what we would do is we would try to say what f of x minus 2 is. And for our function, then that would be x minus 2 squared. If I want to translate it vertically, then you find out what f of x is, and you add k to the output. Remember, it's whether you subtract or add from the input or the output that determines whether you go horizontally or vertically. And so if we're trying to go down, I shouldn't really have a plus there, then we would subtract 3 from the output, and that would translate the graph down. That would be the same thing as x squared minus 3. If I want to do both, well, that would mean f of x minus 2 plus 3, which is going to equal f of, oh, sorry, that's not what I mean to say. That would equal x minus 2 squared minus 3. Okay, so this equation will translate this one 2 units right and 3 units down the way that we're trying to do. Make sense? Now let's actually go ahead and make the graph, and I'm going to make the graph in blue. And to do this, I'm going to do 2 things. I'm just going to go ahead and take the graph that I've already got drawn and translate it 2 units right and 3 units down. And then I'm going to manipulate the new equation that we made to show you how it would give you exactly the same points. Alright, so let's translate the vertex 2 units right and 3 units down. That would end up right there. Then let's translate the point 2, 4, 2 units right and 3 units down. That would take it to 4, 1 right here. And let's translate the point -2 forward 2 units right and 3 units down. That would take it to 0, 1 right there. And then we could draw the graph. Alright, let me label this. Alright, so the values of h and k are going to tell you the vertex of the equation. And since the vertex goes through the line right there, that's the x-coordinate of the vertex, right? So, x equals h is going to be the vertex whenever you're looking at the turning point form of the graph of a quadratic function. And then simply the values of x and h, h and k are going to be the coordinates of the vertex. Alright? And then as far as the coordinate of a point that's not on the axis of symmetry, if you can pick the y-intercept, you're going to pick the y-intercept. But if you can't pick the y-intercept, alright, then just pick any point that's not on the axis of symmetry and plug it in, and you'll be able to graph that quadratic function. Okay, so if you already think you know how to use the values of h and k to find the vertex of a quadratic function, and then you know how to graph the quadratic function from it, go ahead and pause the video and try this equation on your own. If you're not sure, then you can listen. There's not another example later, but you'll still have an idea of whether or not you understand how to graph a quadratic function when the equation of that function is written in turning point form. Alright, so the first thing is that you're going to do with this graph is you're going to graph the axis of symmetry, which corresponds with the x-coordinate for the vertex, and we know that this x plus 3 is going to require you to shift the graph 2 units to the left, 3 units to the left, and so the axis of symmetry is going to be x equals -3. And you can see the line x equals -3 right there. And then the vertex has to be on that line x equals -3. So, as usual, when we're trying to find the vertex, we're going to find out what f of the x-coordinate for the axis of symmetry is. So f of -3 equals 1. You can verify that with your calculator or just, work it out on your own. And so the point -3, 1, that's going to be our vertex. And then since our axis of symmetry is not the y-axis, we can pick our y-intercept for our other point that's not on an axis of symmetry to graph. And if you plug in 0, alright, you're going to get 3 squared, which is 9. 9 times -2 is -18. And -18 plus 1 is -17. Okay, so we're going to need to change our intervals in order to fit that -17 there. Actually, let me erase the point that I already got. So there's the vertex and the y-intercept, and we're going to reflect the y-intercept in the axis of symmetry. So that's going to be at -6, -17. Then you can go ahead and make your parabola, and that's how you graph a parabola when the equation is written in turning point form. Okay, so we've got one more form to look at. You should at this point know how to graph a quadratic function when it's written in standard form and turning point form. And then the last thing that we'll do for this section in terms of graphing is we'll graph functions that are written in factored form. Very good. Let me know if you have questions in class. I will see you then.